When we think of the brain, we typically think of something like this. The brain has a left and a right hemisphere, as well as a small bump in the back that's known as the brainstem. The left hemisphere is responsible for language production and comprehension, while the right side is more responsible for emotional processing. Although the brain presents a unified and cohesive front, it's actually two brains.
Think of it like they're stacked in a trench coat, masquerading around as one brain instead of two.
You may be wondering, how is this possible? The answer lies in the shallow groove between the two hemispheres known as the corpus callosum. It's what makes coordinated actions that require communication between the two hemispheres possible.
The corpus callosum is composed of white matter, which gets its name from the white hue of the myelin-coated axons. Myelin, a layer of fat and protein, improves transmission speeds between neurons due to its insulative properties.
It's the heart, or rather, brain, of what makes the corpus callosum able to function like a telephone line between cities, enabling easy communication between the two. But why is this communication necessary? Like I was talking about earlier, each hemisphere has a different role. The left hemisphere specializes in language, while the right hemisphere specializes in emotion. But there's an extra layer. Each hemisphere also controls the opposite side of the body, meaning that your left hemisphere controls the movements of your right limbs, while your right hemisphere controls the movements of your left limbs. This means that things get interesting when the corpus callosum is damaged or otherwise absent in some way. Some causes of this damage might be neurodevelopmental disorders like agenesis or medical interventions like surgery. When the corpus callosum is damaged, it results in a disorder known as split brain, which is characterized by impaired communication between the two hemispheres.
One famous example of this phenomenon occurred in a study in which patients were blindfolded. When holding a familiar object in the left hand, the split brain patients were unable to name the object since the sensory input went to the right side of the brain. As long as the object remains in the left hand, the patient is unable to access verbal information from the language centers located in the left side of the brain. Another example is alien hand syndrome, or when limbs act seemingly of their own accord. One hemisphere makes the decision to move the hand and is unable to communicate this intention to the other hemisphere.
The existence of these two examples shows that the hemispheres are actually capable of acting separate from each other, or essentially, we do have two brains. They're just united by the communicative capabilities of the corpus callosum, which feeds into the illusion of the whole single brain.